Alright, so my name is Dan Crowley, and I work for Core Security Technologies, and my talk, well, you can see the name of my talk. Let's skip all the introduction stuff, and let's just dive into it, right? Okay, so before we dive in, I just want to mention, pretty much everybody, until I put this disclaimer in, that I delivered this talk to, said, oh, this is great, so we can attack web servers with this, right? And that's it. No. I'm most familiar with web-based technologies, and so most of my proof of concept stuff is on web-based technologies, and actually it branched out a little bit from that since the initial versions of the talk. So it's demonstrated on web-based stuff, but the techniques and principles here should apply to any application which takes user input and interprets it as a file name on a Windows system. So, also, if you can come up with a way to use these techniques that isn't in my presentation, I will buy you a bottle of whatever beer you like. So, and that still stands. So the big problem that we're dealing with is that applications do string-based analysis of file paths. So you get some file name from or a file path from user input, and you compare it based on the string, based on the set of characters. Frequently, this is done to decide how to handle files, or to deny access or allow access to files, or determine if some particular input is malicious in nature. The thing about Windows is that it's very flexible in terms of what it will take for a file name, and many different names can refer to the same file, less fake names, pseudonyms, it's very fun. So a lot of applications won't expect some of these alternate file names. So by using some alternate file names or mangled versions of file names, we can bypass or break a lot of things, and we're going to talk about that in just a second. So since the operating system interacts with the file system and not the application, frequently it does string-based, what I was saying just a moment ago about string-based analysis, and then passes it back to the file system once it's satisfied, where it should be passing it to the file system and saying, hey, should I allow this, or trying to get an idea of what the actual file is. The other thing is that some of these alternate names are based on features that are undocumented. So first we're going to talk about 8.3 aliases. Oh, by the way, nearly forgot to mention, on every slide there is a haiku, which is related to the material, all self-written, correct. So the first thing I want to talk about is 8.3 aliases. Now, the 8.3 format is the DOS format for file names. 8 characters, a period, and then a maximum 3-character extension. In Windows systems, every file, by default, and you can actually change this behavior by making a registry change, but by default, every file has an additional name which is used, well, unless its original file name matches the 8.3 format. If it does not, then a different file name is made for it. And highly simplified, you take the first 6 characters of the file name, add a tilde and a digit for the first file, a 1, for the second a 2, etc., up to 4, and then after that it gets really weird and starts doing some arbitrary hashing stuff that Microsoft hasn't documented. And it's a little bit weird, but on a simple level, so you have the tilde, digit, period, and up to the first 3 characters of the file extension. Anything more is gone. The other important thing to note is that certain characters are completely removed. That is, anything from hex 80 up is removed. Now, why do you care about this stuff? Why do you care about this? Because let's say you have an IDS tuned to look for any string matching highlight.php. So you have PHPBB installed in a system version. You don't want to patch because you have an IPS and it's fine. It'll catch any highlight.php business. So someone requests highlight1.php from your web server, and Apache actually will accept 8.3 aliases as well as a number of other web servers. So Apache says, oh yeah, that's fine, and the IDS doesn't see highlight.php anywhere in the URL. so it doesn't match the regular expression set for the IDS, and so it doesn't flag on it. So we have IDS evasion because of this. Now, imagine that you have a web server which denies any files that start with .ht to prevent things like grabbing .ht password, .ht access, etc. But the 8.3 format does not allow for file names to start with periods. So .ht password becomes htpass_1. Does not start with period ht. So the web server, if it's doing this string-based comparison, is going to say, oh, this doesn't start with .ht. Here you go, buddy. Have a great time with this file. So, like it says on the slide here, forbidden files may no longer be forbidden. And we're going to see an example of this later on in the presentation. Also, the file type might be determined by user input. So when we request a file by its 8.3 alias, it's going to have a maximum of 3-character extension. And if that 3-character extension is recognized as being something different than the full extension before the 8.3 conversion, interesting things happen. So maybe we can upload a phpwned file and request the 8.3 alias, changing it to a .php file, and get code execution. Again, we'll see that later. Additionally, we can reduce, and I'm sorry about this, but the approximate character size set for the 8.3 format is actually much less than I thought. I got some bad information. Who knew that the internet could provide such a thing? But it's actually a 59 character set for the 8.3 episodes. So this is even more effective. But to boil down this slide, because it is a little bit confusing, if we map out the entire space of possible long file names in Windows, it's an astronomically large number. It wouldn't fit readily on this slide, the current font size anyway. Whereas with 8.3 aliases, it's actually, I believe it's 1.4 e to the 11th, which is something like 140 quadrillion, I think. But that's not so bad. You know, we're starting to approach, the entire set of file names is starting to approach a point where we could theoretically brute force it all, given fast enough hard disk read times. Now, when you start to talk about prefixes, known prefixes, so if you have files that start with a certain number of characters, let's say 5 or 6 characters, something maybe like admin_, well then, you only have, well actually, that's 6 characters, so you don't have to, you can just do admin_1, and that's going to refer to whatever file was first created with the prefix of admin_. So brute forcing for file names becomes a lot easier. Now, you might say, well, how can we confirm the existence of files and directories if we have no read access to them? That would be the only time that would be useful, right? Well, we'll fix that later. So, next thing I want to talk about is characters which, when appended to the end of file names, are just completely ignored by Windows, just thrown away, not even accounted for. They're just, Windows is like, what is this doing here? Get away. So in the Windows API, any periods or spaces which follow file names are silently discarded. If you have your laptop open on a Windows system, you can go to the command prompt and try to look at some particular file or look for the existence of a file and just add a period or a space to the end of that file name, and it'll still come back. And an arbitrary number of them still works. In the Windows shell, there's more characters which are sort of ignored at the end. Double quotes, as long as you have an even number of them, that is that they're found to close properly. If you have angle brackets, only in certain strange configurations, they have to all be together right at the end of the file name, and then you could sort of follow them up with whatever you like. Extraneous current directory or parent directory markers with arbitrary items. Some of that stuff is a little bit straightforward, but let's move on. So, if you take a look at these